Find the magnitude of U and find the magnitude of V separately. Is that what everybody else got for those three things? All right, so now let's just plug in. So theta is just going to be the inverse cosine of the dot product, right? Dot product divided by those two magnitudes multiplied together.
Oh, yeah. No. Right, I got it right. I'm not gonna look yet. Don't say the answer out loud. Yes, nobody say it.
I can't put it all in at once.
Oh, hey, you're supposed to be taking your test, aren't you? Oh, is it open? Oh, cool. Yeah. Yeah.
Right, you got it right. He knew it was coming from, right? He was afraid. He was doing great. He was too scared. We'll do it next time. Right. What day is it? Oh, it's Friday. We got him on Tuesday. We're gonna be here Tuesday. Okay, what's the answer? I'm not sure if the host group chat. What? The host group chat. We have group chat. Oh. Yeah, let's leave that one. I was like, what? You're in what? These notes are gonna click. Why are you doing that? No, I just felt like it. Oh, that was funny. Who got it there? It was like something about 2 minutes from class. Yep. At least it's done.
I was thinking, you did it.
Right. So you think you made me step you come over here and check it? Yes. Oh, that was cool. That's the bag. I'm nervous because after school I have to go to guard class and we're doing CPR today. And not gonna lie, I forgot.
I've never learned CPR.
Really?
Like in all my health
Like, I
classes,
know
I've
some
always
of it.
been this.
I'm gonna be the only return guard though, so they're gonna be asking me all the questions. Get somebody else.
Is Emma gonna go?
Yeah, it was.
I can't imagine Emma giving CPR.
Well, she went today.
Why she better report it?
It's not that bad. I can't report it. I found my missing earring. Don't play
Put
with
it in your ear right now.
I know. Wait, but she's not on. It was a little goofy, but I'll put the other one on now.
Right?
Because I don't have a fourth block.
Me neither. They're just my AP exam, yeah, so I just stay for a hop.
Yeah, I'm
Wait,
leaving. Yeah, I'm leaving.
It's okay, you can do the light.
You won't believe it. Guess what? So for the swimming portion, we have to meet them in Somerville at 7:45 in the morning.
Dang, how far away is Somerville?
Like 45 minutes.
So you gotta leave at least by
No,
7.
I gotta spend the night at Emma's house because my car is not going to Somerville. Sorry.
So y'all aren't going to orientation?
No, we can't make it because we have. Well, I already went to orientation last year, so
Exactly, I don't want to make me go
I'm not
again.
doing it again.
I don't want to do it anymore. You're working there? Yes.
At gift shop.
Yes,
No,
Madison.
be a lifeguard.
No, I don't know, but he should be a lifeguard.
Don't even. Actually,
He
Obi
said
would
Emma
eat
already
that
told
up.
him to be one.
Obi would eat that up, though.
He
You
would.
know he's really tall.
Yeah, he
Definitely
could just
save
stand
somebody.
and save someone.
And honestly, when he's telling
Who's
the
that?
kids what to do, they would be scared of him.
Right?
So like us.
Oh, I thought it was highlighted.
Oh my God! Guess
Ooh,
who?
she's glittery.
She is. Guess who we have the class with?
Who?
He
Oh, gross.
was in the group chat.
Alright.
Hey, let's get back to it. All right, so answer to number 6.
Hang on.
Yeah, me and things are all new at this conversation.
They got all the things. Actually, I didn't know he was feeling anything.
Did you get the right answer?
Yes, I did.
Yes.
Good. Okay. Let's move on to the second half of our lesson, which is vector projections. We've covered actually 2 of our 3 objectives. We know how to do the dot product, we know how to apply the dot product, and we know how to tell whether something's orthogonal or not, right?
Yes.
All right.
This just looks like
So-
the same thing over and over again.
Study guide and intervention. It kind of is, except it's not the exact same formula. It's very similar to, though, isn't it? So here we go. A vector projection. What is a vector projection? If you look at the definition here, it says a vector projection is the decomposition of a vector U into 2 perpendicular parts. Okay? Part 1 and part 2. In which one of the parts is parallel to another vector. Okay? One of the parts is parallel to another vector. Now, finding the projection of U onto V is basically finding which part is parallel to V. All right? So let me break that down for you. Projection of U onto V, finding a component of U that is parallel to V. And what you get is you get this lovely formula right here. Projection of U onto V. It's the dot product of U. We're getting another vector here. Notice that when we did a dot product of 2 vectors, we actually got a scalar, didn't we?
Yes.
We went from 2 vectors to just a number. So dot product gives us a scalar, but a projection gives us another vector. All right, so what we're basically talking about is this. Just to give you a picture, and you don't have to write this down. If we had V going this way, and I had U traveling this way, the projection of U onto V, I could change this into its component pieces, couldn't I? This chunk right here that you're going to see, this is the projection of U onto V. Do you understand why? Those are the 2 parts. This is the part of U that is parallel to V. Okay? So that's what this formula is giving you. So let's break down what our formula is saying. Our formula is saying we take the dot product, right? We take the square of the magnitude. We divide those. And then we multiply that by the vector V. This is another vector. So when we get this, we are going to have some answer come out as a vector. The answer is a vector. It's not hard if you know the formula. Okay, so here we go. Find the projection of u onto v. It says find the projection of u onto v, then write u as the sum of two orthogonal vectors, one of which is the projection of u onto v. And I will show you how you do that, okay? It's not that bad. All right, so are we good?
Yes, we're happy.
All right, so let's find the projection. Projection of u onto v. We need to do u dot v. So let's do u dot v. U dot v is going to be what? 16 plus a negative what?
It's negative
18, okay. And then we're going to do v squared. So now we got to find the magnitude of v here, don't we? Magnitude of v is going to be 2 squared plus, so 4 plus 9 is the square root of 13. Yes?
Yes.
So now we're going to take that and put that down here. Square root of 13, but guess what we're going to do with it? We're going to square it. So that just makes it 13, doesn't it? And we're going to multiply that by the vector v, to negative 3. So the top became what? Negative 2. The bottom became 13. So now we just distribute it. This times this, and this times this. It just looks more complicated than it is.
Yes.
Negative 2 times 2, so this would be negative 4 over 13, and positive over 13. Okay?
That's the answer?
That is the answer. That is the projection.
Yay! That was not hard.
We ate that up.
Right?
That's right.
That wasn't the best. I'm gonna do this homework now. I'm gonna eat it. I'm gonna gobble it up.
Is this the homework?
Yes.
Wait, is this all the notes we have?
Yeah.
And I don't really care about you writing it as the sum of two orthogonal vectors.
Yeah, I'm not.
We're not going to do that part of it.
What is the sum of two
Orthogonal vectors?
Yeah.
Yeah. I just want you to find the projection of u onto v.
Yay.
Wait, what? Oh, I was on the homework.
Such a queen.
Right?
So why don't you try number 1 on your own? And if you all get that, then we'll move on to looking at some of the word problems so that you can know how to apply this stuff.
Right. Yeah, you know what?
Just look at the formula. What does the top of the formula say? What does the bottom of the formula say? It's 3 simple steps, okay?
Miss Duffy, how do I get my calculator to not actually solve it, but to just put it in a
The square root symbol?
yes.
Yeah.
Oh, you gotta use the old calculators for that one.
I lost mine. I bought it from Walmart for like $15 and I lost it.
I have one from Pete. And then we'll have to shuffle it around.
Right. Use it for homework together.
Right. I really don't like this thing.
All right.
Don't say the answer out loud.
I won't say the answer out loud.
I don't know how to do it. This don't seem right.
Don't forget.
You have
Oh my goodness. I did right.
I have
Uh-oh.
a question, but I'm not going to the board because I don't want to do it.
Okay.
Oh wait, never mind. This is a silly question.
How did you get? How was it over the slide?
Wait.
Don't
say
say
about-
anything.
Sorry.
It's okay, Vicky. I get this wrong when you said that.
What? I'm confused.
Oh, because I put the wrong answer down.
Oh,
Please.
the board, yeah, it's a little strange.
Sorry. I looked at it. I put the completely wrong answer down.
Wait a dang minute.
Yep, I ate.
Oh wait, I got it.
Wait,
Right.
Oh, thank goodness.
I'm almost done.
Sorry about that, guys. Seeing if
I
you're
got it
awake,
right,
right?
Stephanie.
Good. All right.
Max,
Wait,
am I done
wait.
yet?
Okay.
Done. I'm basically done.
I'm literally gonna gobble this homework up.
All right.
Okay, I got it. Right.
Yep. Okie dokie then. So let's look at, you're good to go. So let's look at one more of these just for the people at home who aren't here, taking the A push and
That's
walk
so
through.
fake.
Y'all are
So
all fake.
U dot V, all right, let's be nice. Negative 56 plus 15. This would be
Except Caleb.
negative 41. Magnitude of V would be the square root of 64 plus 25, which would be the square root of 89. So we're going to plug this into our formula. So the projection of U onto V is negative 41 over,
89.
yep, square root of 89 squared times V. 8 over 5, 8, 5, right? So what we get is negative 41 over 89 times, and we're just gonna multiply that in. So that would be negative 328
What in the world?
over 89, and then negative 205 over 89. And that would be the answer to.
Yay, let's just not do the word problem anymore.
All right, so we're doing the word problems.
I just don't.
I know, but y'all don't.
It just, it makes my head hurt.
Oh, you know what? It'll be
Like,
all right.
My head was already hurting, but then once I get to the word problems,
I'm just like, ugh.
Now, remember, you do not have to write it as you just have to find the projection, right? So we're finding the angle, we're finding the dot product, we're looking if they're orthogonal, and then look down here at these, and please understand that they are not hard.
hey, whatever.
Train A and train B. Look, if you take time to read it, you've got a vector here, right?
Yes.
We've got another vector here. What's it asking us to do? Find the angle between. So that's just like we were doing right up here. So it's really not that bad. Now, Jana's using a force of 100 pounds to push a cart. The ramp is 6 feet long at an angle of 30 degrees with the horizontal. How much work is Jana doing? So, we know that work is equal to F dot D.
Was that force, not direction?
That is force dot direction.
Miss Steffi, can we talk about what number 2 is?
With the I and the J. Is it the same but just different looking?
Yeah,
Oh.
this is,
So it would be negative 1, 4.
yep.
Oh, okay.
And this one would be,
3, 2.
I saw the I and the J and I was like,
and you're going to dot those, yes.
okie doke.
All right.
To make sure.
All you have to do is find the force, guys. All you really have to do this problem is find the force. What was the force?
100 pounds.
100 pounds.
100 pounds, okay? And it says use the sign ratio. This is really just F perpendicular. So this formula, F dot D, do you know what it becomes? It becomes FD
D S.
sine theta. Do you know why it's sine theta? Because we have to find the force, the force that's going in the same direction we're pushing the box, don't we? That's what the dot. Think about it. Orthogonal means perpendicular, doesn't it? So here's your quick physics lesson of the day. If I want to move this book across that table, I have to be most effective at it, I have to push it straight on, don't I?
Mm-hmm.
That's parallel. So if I want to move this and apply a force and I do this, if I apply it orthogonally, is it going to move the book?
No.
No,
No.
probably not very fast.
So now if I move it at an angle, the part that's actually pushing it forward is the part of this vector that's going parallel to it, isn't it? Well, I want you to think about it. If the angle is here, right? The angle at which I'm pushing, this is the sine component, isn't it? Think about it. It's opposite my angle right here from me pushing. This angle is like with my arm, right? So this part is the sine portion of it. So you just do FD sine theta. Okay? So, what is the angle?
30 degrees.
Yep, so it's 100 times, how far are we pushing it? 6 feet. And the sine of 30 degrees. Okay. So we can do that. Now, and last but not least, and I'll let you work that one out. Sine of 30 is 1/2, isn't it? Okay, so let's look at a few of these and see what we've got here. The path of the submarine can be described by a vector. The submarine then changes direction and goes this way. What is the distance traveled by the submarine?
Is there a distance forward?
No.
Is it just the same?
I don't know.
You just put like
I know what you mean.
miles or something at the end?
No. So let's talk about this one. How would we do this one?
Is this what we do with
No.
the dot problem?
I'm gonna give you some weed.
I can go to my mom's room. Yes.
Did Office Depot close?
Yes.
Yeah. That's a sad day.
I found them in my mom's room. I have 2 of them, each one. I know. I'm so tired.
Let's just.
I'm about to take a nap. But I
Same thing.
Maxie, who are you subscribed to on Snapchat?
will. Sadie Crowell.
Right?
The True Queen. Bye.
Hey guys, shush.
Oh, sorry. Wait, why are you going?
She's trying to figure out how to solve
Miss Duffy, if you can't figure it out.
I can figure it out. I just want to make sure I'm giving you the correct, I know what the answer to it is, which I finally just found. All right.
I have no hope.
Never heard that saying.
You can. Guys, how far did he go? If he went 8-3, what does that mean?
He went 8 miles east.
Yeah, he went 8 miles
Okay,
east
actually-
and then 3 up, right? So his first path was what? His first path was this way, wasn't it?
Yeah.
You're so smart.
I actually.
And then from there, what did he do?
We went 2 miles.
He went 2 this way and,
It's 5.
No, he changed direction.
yeah,
What is this distance?
But wouldn't that be him going the same direction?
nope, because he went 2-5 this way. So he did change direction, didn't he?
Yes.
Oh crap! I'm just gonna get in an energy
Okay, so how do we figure out how far he traveled?
We have to do the vector.
This is
Don't you have to do
V, isn't it? Guys, if we want to know how far he traveled, it didn't say the magnitude. It said, what's the distance he traveled? That would be how far he traveled this one, and then how far he traveled on this one, wouldn't it? Isn't that how far he traveled the magnitude? Isn't that the magnitude? How far he traveled. How long that vector is how far he traveled.
Yes.
So that would be the magnitude of V.
Yeah.
And then what would this one be?
A magnitude of E.
And then what do we need to do with those two things?
Add
Add them together. Now 2 is easy because it just gives you two vectors and asks you to find the measure of the angle between them.
I'm trying to get my keys off.
This one's just a work equals F dot D, right? Or FD sine theta. How much work are they going to be doing if it's 90 degrees for the horizontal? What is the sine of 90 degrees with the horizontal?
Is it?
Did I give you that formula wrong?
What? Did you see? What's right here?
Sine of 90 degrees is 1, isn't it?
I brush my hair when I'm bored. Wait, I forgot what I was gonna say. But yeah, what's up?
I don't know. This isn't what you were saying.
Scissor?
I think
Or was it snooze?
I think so.
You're right.
Yes, it was. It was. It was. Oh, that's. I'm not gonna gobble these word problems up.
I'm just really tired.
This one's easy. If she's trying to pull the boat forward and all she's doing is, and the rope that she's pulling with is 90 degrees to the horizontal, how much work is she going to do? How far is she going to be able to pull the boat forward if she's pulling up?
Nowhere.
So how much work has she done?
0.
Okay.
Where's the J?
Joules
Joules.
for work.
Okay.
0 joules.
0
It
joules.
looks like OJ.
Wait, where do y'all see joules?
Joules is the
I know, but like, where do y'all see that in the problem?
I just know it.
Oh. Good for you, girl. They sure don't.
It's a physics thing.
right. That's very suspicious. Physics and math.
Right, they should not be combining.
All right, let's see. I want you to do six on your own. And I want you to do 2. I want you to finish 1. And hang on. Pilot is carrying a bag, weighing upstairs. What's the length of the staircase?
Oh man, you walking? I thought I'm done with day off. Sad day.
No, he's just early.
Okay,
Really
so are
early.
these the only ones that we have to do, the ones that you're telling us?
Yeah.
So which ones did you say? 6?
6.
1,
1 and 2.
2, 6, and yeah, that's it.
6, that's it?
1, 2, and 6.
Yay, I already finished 3, so can I exchange that for another one? I'm just
No. No, but that's it. All right.
Okey-doke.